Alright, in this video we're going to go over projectile motion example calculations. So when we're dealing with projectile motion problems, we have to break it down into two components. The x component, which is the horizontal, and we use the formula v equals d over t, which we've gone over before, and we use the y component, or the vertical, up and down. We use this formula, the free fall formula, which we have used before as well. So to solve these problems, we're going to use this graph on the left here, y and our x. We're going to break it down into two components. Remember, for the y, this has a y on there. That way you know that we use that to find the distance in the y-axis. And then we break it down here on our charts. We write down all our variables, all of them for y, the vertical, and all of them for x. And so here's the formula again for velocity. Okay, this is something new that I have not described before, but it's an easy way to find your variables. So for example, let's look at this circle. Let's say you wanted to find velocity. Okay, so we're looking at velocity. Okay, that means I'm going to take distance divided by time. And that makes sense. V is d over t, which we already have. Let's say you wanted to find what distance is. What is distance? Well, distance is v times t. D is v times t. And that's why they're together like this. If you wanted to find time, how much time it took in the horizontal, then you would have d divided by v. T is d divided by v. So this little circle is meant to help you find the algebra behind it. So if you want to do it this way, you can. If not, you can just use the algebra to find each variable. So to review this, to find v, that's d over t. If I wanted to know what d is, then I would multiply v times t. So when we're horizontal, we multiply. If I wanted to know what t was, I would take d divided by v. So a stunt driver steers a car off a cliff at a speed of 20 meters per second. He lands in the lake 2 seconds later. So let's underline our info. Find the horizontal distance the car travels and the height of the cliff. Okay, so let's break this down. So I've highlighted our what we need for each section. So if it's in purple, we're dealing with the x horizontal component. If it's in blue, it's the y component. And I highlighted time in green because it's very important that for you to know that for each dimension, whether you're in y or x, time is the same. So that is the only thing they share in common. So if it's 2 seconds here, it's going to be 2 seconds here as well. Okay, so let's start with our graph. Let's draw that. So it's falling off a cliff, and our horizontal velocity was 20 meters per second, and it was at time equals 2 seconds. Okay, so our vertical velocity was 20 meters per second. And now it asks me, what is the horizontal distance? I need to find dx. So let's just plug in our numbers. So v is 20 meters per second equals dx. I don't know dx. That's what I'm trying to figure out. And my time is 2. So to find this out, I just cross multiply. So 20 times 2, which would be 40. And distance is in meters, so dx. That's how we figure that out. So this would be 40 meters. Now you could also use this circular way of solving for the problem. So for example, we were looking for dx, so we had to multiply v times t here. So you could skip this cross multiplying step and just multiply 20 times 2, and you would still get 40 meters. So whichever way you feel is easier, you can either use the left side or the right side. Now for the y component, remember the y component is pretty much like a free fall problem. We have been doing those problems. And in free fall, when something falls, initially the initial velocity is going to be 0 meters per second. And acceleration is always going to be 9.8 meters per second squared. And so for each of these problems, these two on the y component are always going to be the same. So you can at least have that already filled out for your y component. So let's find dy, or the height. So dy is equal to initial velocity, which is 0, times 2 plus 1/2. Acceleration is 9.8. And my time is 2, so it is 2 squared. So here, 0 times 2 is just 0, so we can cross that out. So I'm going to simplify. I have 1/2, 9.8, 2 squared. So 1/2 times 9.8, this is equal to 4.9, and 2 squared is 4. So 4.9 times 4 is equal to 19.6 meters, and that is my height. That's dy, 19.6 meters. A horse running from a honey badger jumps a horizontal distance of 10 meters off a cliff. The cliff is 20 meters tall. What was the horse's horizontal speed? So let's first draw a trajectory. So it's falling off, and all the info we have is that it's 20 meters high and that it's 10 meters off the cliff horizontally. So let's write that down. So 10 meters horizontal, that's dx. And my height of the cliff was 20 meters. Okay, and so the next question is, what was the horse's horizontal speed? What is v here? Well, I can't find v here because I don't have time either. So what is time? So I can't do anything with x yet. So I have to find something. I have to find time using the y, the horizontal. So let's figure that out. So first of all, we can already fill in some information. We know that acceleration on the y, or free fall problems, is always going to be 9.8. And we know that initial velocity is 0. Now let's find t. So dy is 20. And my initial velocity is 0. And my time is, we don't know time, plus 1/2 a, which is 9.8, and t squared. We don't know t yet. So I'm going to simplify this. So 20 is equal to, we can cross this out because anything times 0 is 0. 1/2 9.8 t squared. So 20 equals 1/2 times 9.8 is 4.9 t squared. Now to get t squared by itself, we have to divide both sides by 4.9. 4.9. So we're left with t squared equals 20 divided by 4.9, which is around 4.08. So we're left with t squared, so we don't want t squared, we want t by itself. So to get rid of a square, we have to do the opposite, which is to square root. So we're going to square root both sides. And our t is equal to around 2.02 seconds. So luckily with time you can use it on both. So I'm going to color code 2.02 seconds, and I can put that also on this side. So now I have distance and time, so I can figure out velocity. So let's figure that out. So velocity is just d over x, so 10 meters divided by 2.02, and this equals around 4.95 meters per second. Take the time right now to solve this problem on your own first before I even go over it. You can pause the video and try it on your own. If you're still having trouble, then of course I'm still going to go over the problem here. So Daniel's running away from that kid that keeps making videos to him due to his abnormal obsession with vans. In Daniel's haste, he did not realize he was running off a cliff. If the cliff is 40 meters tall and he lands 20 meters away, A, how long did it take Daniel to hit the water below? B, how fast was Daniel running as he launched off the cliff? So I decided to, again, I color coded. Anything that's on the Y is blue, X is purple, and time is the same on both. So let's draw, first of all, let's draw the trajectory. That's your first step. And the info they tell me is that it's 40 meters tall and that it's 20 meters away. Kind of similar to the last problem where they only give us the height. So dx is 20 meters away, and dy it's 40 meters tall. Okay. So first question, A, how long did it take Daniel to hit the water below? So he's falling. So if he's falling, then we're dealing with a y component. So we can start off with y. So A is always going to be 9.8 and V is 0. So remember, this is always the same for each y component. So let's find t. So dy is 40. Initial velocity is 0 times t, I don't know what t is, plus 1/2 9.8 t squared. Now let's simplify. 40 equals, well, anything times 0 is 0, so I can cross this out. Okay, 1/2 times 9.8 is 4.9 t squared. To get t squared by itself here, we have to divide both sides by 4.9. And so that crosses out there. So t squared is equal to 8.16. Approximately 8.16. Again, we don't want t squared by itself, so we have to do the opposite, which is to square root. So t is equal to around 2.86 seconds. So I'm going to color code because remember time, I can use it for both components. That's the only thing that's the same on both sides. So 2.86. Now I can figure out B. How fast was Daniel running as he launched off the cliff? So we just use this formula down here. So V equals dx, which is 20 meters. That's how far away it was. And our time is 2.86. So our velocity is approximately 7 meters per second. To assist Bob in learning about projectile motion, King Leonidas kicks him in the pit with a velocity of 4 meters per second while yelling, "This is physics!" Bob times his fall and realizes it takes him 2 seconds to hit the ground. A, how deep is the pit? B, what is Bob's range? Anyway, this is a cool movie, so we can finally use some physics here in cinema. Okay, so you can pause the video again, try to do this by yourself first, and then you can see how I solve it. So first of all, when we have a problem like this, we have to draw our projectile, our trajectory. So first of all, when he threw him and he said this is physics, he threw him at 4 meters per second horizontally, and that took 2 seconds for it to happen. So A, we're trying to find out how deep it is. Okay, so let's fill in our info first to see what we have. So we don't have dx, we don't know how far the range is. We know the velocity horizontally is 4 meters per second. And we know time is 2 seconds. Remember, time is the same on both sides, so I can fill that in. Let's see what else we can fill in. Well, on the y-axis, we know that acceleration is always 9.8, so we can put that there. Meters per second squared, and initial velocity is 0. Remember, this is always the same in y. So we don't know dy and we don't know dx. Okay, so let's look for the first one. How deep is the pit? So we're looking at the y component, dy. So initial velocity is 0 and time is 2 plus 1/2 9.8 2 squared. So here we can cross this out because we know that 0 times anything is 0. 1/2 times 9.8 is 4.9, and 2 squared is 4, so 4.9 times 4. So my height, or how deep the pit is 19.6 meters. So I can put that here, 19.6 meters. Now I can find my dx. So I can just use this. If I'm using this side, I can just use 4 equals dx t, which is 2. So then I can just cross multiply. So dx is equal to 8 meters. Or you could have also used this. So dx is equal to v times t. So I could have just said 4 times 2 is 8. Again, 8 meters. So whichever way you like to solve this problem, you can use whichever equation manipulation that works for you.